Welcome to the 7th section of this course, Model Evaluation. In the previous section, we took a look at neural networks and support vector machines. In this section, we will discuss how one can implement a simple R script or use one of the packages, for example caret or rminer, to evaluate the performance of a fitted model. Let's begin with the first video of this section, titled Estimating Model Performance with K-fold Cross-Validation. In this video, we implement a simple script performing 10-fold cross-validations. Let's get started. The K-fold cross-validation technique is a common technique used to estimate the performance of a classifier as it overcomes the problem of overfitting. For K-fold cross-validation, the method does not use the entire dataset to build the model. Instead, it splits the data into a training dataset and a testing dataset. Therefore, the model built with a training dataset can then be used to assess the performance of the model on the testing dataset. By performing n repeats of the K-fold validation, we can then use the average of n accuracies to truly assess the performance of the built model. In this video, we will illustrate how to perform a K-fold cross-validation. Here we will continue to use the telecom churn dataset as the input data source to train the support vector machine. For those who have not prepared the dataset, please refer to Section 5, Classification I, Tree, Lazy, and Probabilistic for detailed information. Let's perform a few steps to cross-validate the telecom churn dataset. First, you need to load the E107 package as library E1071. Then split the index into 10-fold using the cut function. This is the code for that. Next, use for loop to perform a 10-fold cross-validation. Repeat 10 times with the help of this code. It is running now. It's completed now. You can then print the accuracies. This is the output. Lastly, you can generate average accuracies with the mean function using this code. You can see the mean value here. Also, if you wish to perform the K-fold validation with the use of other models, simply replace the line to generate the variable fit to whatever classifier you prefer. For example, if you would like to assess the naive Bayes model with a 10-fold cross-validation, you just need to replace the calling function from SVM to naive Bayes. This is the naive Bayes function, as you can see. Run this code. So then you can print the accuracies and calculate its mean using the code. This is the output. Great! So this video walked us through the K-fold cross-validation for estimating model performance.